Let's start our circus.
Circus.
Yeah. By the way, I'd like to show one quite important video for you. Yes, from actually, unfortunately, it's in Russia, but okay. So.
Wolf weaker than lion.
Or tiger, but he is not participating in the circus.
Okay.
So first of all, you may see the wolf in circus. A second one that. So Vasily told me that it's me and the other students is the wolves. Okay, so because when I was on previous batch, some students from linear algebra told me that we are wolves, we won't participate in circus in front of the whiteboard. So I have the proof that even wolves. Yes. Okay. Now you may ask why we are having the class today if you have a midterm. The answer is that unfortunately the previous year I didn't do this and we didn't have time to pass all, let's say, parts, yes, of the course. And it's the reason why.
One lab behind.
Again?
Aren't we one lab behind or something?
We didn't take a lab for dynamics.
Yeah, that's right.
You didn't have? You have. You already.
We had lecture in dynamics,
Yes.
but we will have today lab in dynamics, right?
Yes,
That's
exactly.
why.
So we have one gap, between lecture and
Yeah.
lab.
One lab behind.
Yes. If we wouldn't do this, in this case we would have two. Yes. And it's not very nice. So, about dynamics. Today we are covering what does it mean, inertial systems and non-inertial systems. Bam. Manifold problems. Actually, in the algorithm, we will discuss about it when we start to solve the task. Because actually we have three big parts. Is analyze the system. By the way, okay, I will ask this question later. So analyze forces and solve the problem. Actually, we may say that also we have not only analyze forces but also kinematics in some cases. Now we are working with particle. In this case, we may say we are not having kinematic itself, but later when we will work with mechanisms, in this case, we also need to consider kinematics. No, I already started it. At least, yes, it works. Now we are going to the kind of forces we will face. Constant forces, time-dependent forces, velocity, and position-dependent forces. As you may see, it's when we have mainly we probably used to work with respect to time or constant. Now we work with respect to position and so on. Now I'll explain how they look like. Yeah. Constant forces. Gravity forces in general, or when we talk about Apple and Newton. Resistance forces related to velocity. Actually, we have do you understand the difference between this and this one?
I don't.
We have it's resistance forces, as you may see. So when we have running person, he is not very fast. In this case, we can consider that his velocity respect to class velocity. If we are talking about missile like this or bullet and so on, we have to consider that it have say velocity in square. In terms of
So it's dependent on somehow, because I asked the professor when to use each one, and he said it's a very difficult task to choose which one to do, and it's usually given.
in real task you just need to thing. So, for instance, we're talking about bullet, some small object which move relatively fast. In this case, we're considering this one because, as you may see, it has v. So in this bolt. So in this case, you're also considering the direction, not only the magnitude itself. We will have task for this and for this. Of course, it's very simple. It's a very simple model of resistance force because in this case we just have one coefficient, k or nu in this case. Of course, when I talk about bullet, if you open some dissertations, PhD thesis about this, you will see a lot of formulas because they're trying to consider this movement, screw movement, and so on and so on. Control forces. Actually, you already had a control course, and probably you faced with it on their course. So respect to time, respect to acceleration, respect to many components. Kind of different equations. In some cases, we can. Why I'm putting there? We can consider that when we're solving our task, we divide it in two big parts. One is, let me say, how I call it, creative task, yes. In terms of we need to prepare equations in the end. And second one, we need to solve, integrate all the system. We can say that it's routine task. Of course, for some cases, you cannot solve it analytically, you have to solve it numerically, and it's the reason why I use coding in this place, because you cannot do it otherwise. If we're talking, of course, about more complicated systems than just, like board, which try to move along x direction. We have constant force, we have bam, 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 and there too. It's respect to time. In this case, we will have exponential. For resistance forces, for linear, in this case, you may see that we divide on x and y axis. So we are putting on the basis projection. And position dependent forces. So depend on parameters, and you may see a lot of very awkward and scary, spooky equations. Actually, it's our, cheat sheet. I call it like this. Today we will see. On the previous year, I spent about probably 2-3 days for making a very helpful, at least for me, table, which consists all possible approaches which we will use during this class, this course. It looks like this. You will receive it in the end. Okay, I will close. And it consists of, so in this case we are talking about method, what the research object. As you remember, I told you that the first time you write research object, so it can be particle. Today we are working with particles. After this with systems, body system, body or one body or system in general. How many equations we can receive through this method? Because, for instance, we used to think about why do we have 3 equations there, x, y, z. In some cases, it's dependable. Depends on the amount of bodies. In some cases, Euler Lagrange, it depends on degrees of freedom of the system. In some cases, for instance, you may think, okay, there is only one equation, and there we have 3. Why we are not using this one? In some cases, it's much easier. We can solve just on the fly if you're using one method, simpler method, than using more complicated. To sum up, most of the tasks, relatively simple tasks, can be solved using either Newton-Euler equations or Euler-Lagrange. For instance, Gazebo use enhanced version of Newton-Euler. Most of this, because it's numerical solution. Equations the PES application where you can be used. So for instance, for today we're talking about particle. For everything, if you can represent your system or body as a particle. And additional comments. Like today we are talking about inertial and non-inertial system, and what does it mean non-inertial system? So you will receive this table in the end of the course. Bam. Now we are going to the task. No. Because right now you know only particle and actually we haven't started to learn it yet. I don't see any reason to give you right now. It will be your my gift to the final exam. Yes. So now we are going to the first task.
May I ask?
Yes.
What's different between inertial systems and non-inertial?
How can I explain? How I understand it? Actually, it should be. Okay, let's omit all Newton's law. Is for smart guys. We are not smart there. At least I am not smart. How do you understand?
Like if there is some kind of conservation or maybe displacement, like when you push the object and it keeps moving, then
It's called acceleration, right?
it's maybe like think as an inertial force that you apply to the body and it continues moving. And if it's non-inertial, it may stop like exactly at that moment, even if there is no friction.
Okay, Andrew, how you understand?
Non-inertial system would be a system that is moving with some acceleration with respect to the inertial one. In this case, of course,
Look at his face. I can say much easier. This boat, we have coordinate system related to the ground.
Yes.
Inertial system. Bus and the people inside. When we have a point. Do you remember the when do we have the Coriolis acceleration? You have some rotation stuff, and the point also move inside of this rotation. It's exactly non-inertial system.
Okay.
Because in this case we have accelerations. I mean, our coordinate frame not moving constantly, or so when you have your coordinate system is moving, but with acceleration. If it's just moving constantly, you also can consider the inertial system. Like our Earth moving I mean, probably it has some accelerations, but we can neglect it for our tasks.
Yeah.
In this case, so if you have some accelerations, or just it moving somehow, not very, let's say, constantly, not constantly, non-inertial system. If
Okay. So understood. Like if you have two origins and one of them moving with at max constant acceleration, then it's an inertial system.
if one system are either constant, so like I want to calculate dynamics for this guy, and I consider that my system of, my coordinate frame is a table at this point, it's inertial systems.
Okay, nice.
If my table start to, I'm considering that my my coordinate frame is this guy, I also mechanic and I accelerate this stuff, non-inertial system. Because in this case I need to compensate this non-inertiality. Like this. So at least I'm understanding in this manner. Everybody got it?
You were told that in inertial systems objects move with constant velocity unless a force is applied to them.
I wrote that. So inertial forces, it's not a real force. It is needed to compensate it, first of all. So this acceleration, Coriolis acceleration and Coriolis force. What again? Coriolis. I don't know. Moletov, I think it's not the best case for yes, credential. I don't know how it will be in English. So core star you know?
So it is-
Yes. Do you know how it will be correctly?
I have a problem with the R. Like,
But I mean, where we need to make stress. Coriolis or Coriolis?
No, the second one.
Coriolis.
Coriolis. But I cannot
Okay.
pronounce it.
Okay. So core star. It's enough. How it's called? Это регулярное выражение.
Regular expression.
Yeah, what? Regex, yes. Regular expressions, yes. Regex, yes. So yes, we are using regex for this. And again, it's not obligatory that particle should be on a body, like turning bus or a man. Again, it can be Earth and satellite on Jupiter. It's exactly what I showed right now, though. It can be either, let's assume there's a bus, and it moves and rotates with acceleration, and I try to calculate dynamics for this. In this case, of course, how to say, it is a non-inertial system. But also, as I showed it before, it moves, but my coordinate system is there, and my position there, and I'm moving with rotation. For totally having the again, we have relative acceleration. Not only so, if we are not having Coriolis acceleration, in spite of it, it's non-inertial system because we need to. Okay, we will solve the task and you will get it.
Just a question to make sure that I understand. So if we take our frame of reference, for example, on the sun,
Yes.
then it's inertial frame of reference. But considering the other planets, like if we are studying
Yes.
the other
Okay.
planets,
If we consider the sun is not
the sun
moving.
is stationary. Yeah.
Yes.
we're just
Yes. In this
like
case, yes. Yes.
hypothetically. Okay.
We can consider Earth also as a inertial in some cases.
Yes. We are doing this right now when we're saying that the stable is a.
Okay, so it's just a question of choice of the origin. That's it.
Yes.
Yes.
Exactly. Because of origin or frame. Okay. Let's go to this task. The easiest task ever. Did Maletov show this task? No.
No.
Okay, because I don't know what he did during the lecture. Probably you are not visiting the lecture, they know. What's the percentage of attendance? 15? 50, okay, yeah. 15. Okay. So, again, the presence of research object and type of motion, you can choose the algorithm. We will do it right now. Don't forget to put the coordinate frame. Each task can be divided into two big tasks, obtain equations and integrate them. In simple cases, we can do it analytically, otherwise numerically, I told you. Explanatory sketch and kinematic scheme are different stories. What I'm talking about? What is it? Is it kinematic scheme? Or what is it? Or explanatory sketch?
It's just a sketch. We can model it, I think, as a part.
How can you understand what's the difference? So, I need to understand the task. How it moves, how it moves. Okay, I have a board. Let's make, I don't know, anchor, yeah. So, let's put anchor. Will it help us to solve this task? No. Oh, I think that we need, so we have some rocks. Let's put some trees there. This explanatory, sketch. But for this task, we can consider this board, okay, I'm saying this before, as a particle. So because we have task about particles right now. So in this case, I don't need to draw any rocks, any boards. I can just put coordinate system x, y, even I don't need y there, or probably I need because I have mass. And I have particle there. So in this case, I add some forces. And hooray, I'm solving this task. So, explanatory sketch, kinematics scheme. For some purposes, you can make both if you didn't get something. You can combine them together, but at least you need to distinguish kinematic scheme and this one. Okay, in some cases it's necessary to draw a scheme with different conditions. We will face with it probably when we will start to work with oscillations. Because in this case we need to draw different pictures. Okay, let's read the task. Both have initial velocity and mass. We have also resistance force, which affects on the board. There are two subtasks. Equation of motion, so we just need to solve the first task, let me say like this, and find the time. Why we are considering there that this task can be solved as a particle? Because we don't know anything about dimensions, shape, and so on, and probably for such kind of task, we can assume that it's not very. We won't have any quite big error when we consider it as a particle or probably with a fancy shape. In first glance, of course, because we are trying to consider probably the water dynamics, like our water streams will pass through the. I think what it's called, the first part of the noise, and this. In this case, of course, it will be completely different skill. Research objects. The board. Particle. We represent it's a particle because of task description. Can neglect the size. It's better to explain on quiz or whatever, because it helps you to understand why you choose this precise way of solving. Motion. Rectilinear. Second Newton law. I'm choosing the coordinate system there, hence I have inertial system. In general, of course, we have second Newton law, but we can, let's say, explain it more explicitly and say that for inertial systems. In this case, we don't need to consider any acceleration. Okay, we did it. Nice. After this, conditions. Quite crucial. Because without it, we cannot solve our integration task. We need to say about x. First of all, we need to understand what the general coordinates. Have you heard about this word? You should heard it in physics.
General coordinates?
Yes. Обобщенные координаты in Russian.
But let's expect with this. It's like who? Like,
Yes.
Yeah, we've seen it in the control theory.
Yes.
Examples.
What is it? Did you get it?
As far as I said, it's just like it's like what we get from Jacobian. It's like just some coordinates that map to the physical world that are more convenient for us to use. Something like that.
How did you get it in control theory? So
Which one in control?
you have control part. Oh.
Dot.
Yes.
Double dot.
Окей, манипулятор, который
It's just like,
Yeah.
from what I understand, it's just like coordinates that we construct with the.
No, actually, we have degrees of freedom of our system, and we can uniquely represent our system using these coordinates. It's called generalized coordinates. Like when we have, for instance, we have one dot manipulator. No, not manipulator, whatever. It rotates. How I can represent of course, length and so on, we are not considering this. How can we represent our rotation? At the angle. We used to do it on, so our generalized coordinates is theta. But I can also make that it will be xy. Of course, in this case, xy are, let's say, they are dependent to each other, cosine, sine rule. But in general, I can use it without using angle. So we generalize coordinates. In our case, x coordinate is generalized coordinate there. Because we move along x-axis and we don't need to add anything else. We can describe our system using x, yes, as a variable. So we have at 0. So yes, how you don't need to write it exactly and right now. We have initial condition. we have final condition. Thanks. Okay, let's call it like initial first. End. What will the task? Speed will be reduced quite, yes. Or you can say that like task. It's first some task and for second subtask. Like this. We have x dot, x2 dots. Half not x2 dots, we don't need it because we will receive an equation, sorry, time. In the initial position, what the x should be?
At the beginning of our reference frame.
You are choosing where it should be. Actually, we may say that it's equal to 0. Because we can put our initial system just in this point. What should be our initial velocity?
V0.
V0, we have it there. Our time?
It's not given, but it's time 0 for initial.
You can choose it. We can say that I want to, okay, what's the time for today?
Yeah, but we can start from 0.
We can do like this, but if it depends on the time, it might have some ideas. But for our case, we can say it's equal to 0. But we can put any time there.
You want to write x dot 0?
X dot, yeah.
0.
0.
Yeah.
Yes, time 0. For this case, we don't know anything. Because we are not interested in, how to say, in some particular places. What about second one?
X2 equals x final and x2 dot will
X2
be
what? Do you know what will be
just
X2?
like some variable. We don't know it yet. Yeah, okay. It's the same. And this will be v over 2.
So now we are understanding what's going on there, what should be, let's say. When we will integrate it, we need to understand what will be the ending of this. Now we are drawing the, actually you can do it parallelly or whatever, what you like. We have point, it will be 0. Our reddish. Archimedes force. Брось. Или там кого? Честь просто принял. Velocity. In our cases, it's not really, it's not reasonable to draw several pictures because it won't get anything of us. But in some cases, it might be useful. Okay, we wrote conditions, we wrote motion. What we're doing next? Force analysis. We have G. We don't know FA. We know do we have K? Support, blah, blah, blah. Let's assume that we have it. We know the resistance force of the. Now, okay, we did everything. We draw, we put the reference frame, we put initial, conditions, motion. Now we can solve it, finally. Solution. Let's solve first step. According to equation,
Should it be FC? Not VC.
Yeah.
And should we say like that there's some force that pushes the rope forward because it's not satisfied? We have resistance. It means that it goes through, right?
Maybe it was like
There's
pushed
no-
and
Okay.
somebody left it.
You have
Okay.
acceleration.
Okay.
You have acceleration.
Okay, the acceleration.
It's common mistake. All of people made this, even me at first.
So
time.
acceleration is zero?
What again?
Acceleration is zero?
No. It's negative.
Okay.
Don't worry. Actually, you should know it from school, as Gorchevsky told us. Yes. So I remind you the equation there. Ma equal to sum of forces. Mass of the particle. A is this, and force also is vectors. Okay. So we can check that yes, ma force. We are writing Ma equal to force A plus mg plus Fc bar. Put it on the basis. X mx2 dots equal to minus. So we don't need to know, we put these forces, but we don't need it because it's useless for our task. Because x2 dot will be equal to, or xy2 dot will be equal to 0. And it's just useless equation for us. So we have equation for mx2 dot equal to x dot.
Second dot.
We are integrating this guy. What's it?
Initial speed.
Where we will take?
X0. V0.
So we are taking from this region. Yes. If you understand what's going on. Okay, actually, we received all the stuff. We may say that we solved the first task. Because according to the first task, we need to find the equation of motion.
Mm-hmm.
Equation of motion. Now we are going to the second task. We are taking this one. Не, смысл тут нет.
C2 is our additional position.
We didn't find the equation yet, my mistake. Because we can put f equal to 0.
No, you know that x0 is
V0. And x0. X dot 0. It's V0.
yes, this one x0. You know.
Otherwise, we wouldn't move it
No,
on.
no, 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 we are trying to find one. Because we
Yes,
don't know this.
you know v0.
Yeah,
Yes.
we need to find one after this. And after this, we are putting it in.
E plus C1 is equal to V0. If plus 1 is equal to V0, not 0. Yeah.
We are finding this one after this one. Okay.
Are these like lines, like directed arrows?
C1 is not power of E.
C1 is like in the bottom, and are these arrows or
Ah,
not?
it should be there, C1, yes.
Yeah. And these are arrows, right?
Arrows, yes.
Ah, this one is arrow. Okay.
Yes.
And
Just we need to find C1 because our code finds C1. We put initial condition finds C1.
Okay.
So we receive these equations. This is what we are doing for the second task.
We need to find the final.
So we just need to substitute conditions
Or f equals b0 over 2.
and we'll find T. So we solve this task.
But wait, where's our t in the equation?
We put it 0 because it's 0.
Ah, so this. Oh, okay.
Because we found C1, C2, but we received there and we put in all conditions there. Now it's yours. Your turn.
Me?
No.
This mass number.
На неуниверсальный зануда. I told you that the nerd of the next one. You are nerd. We will solve this task till the end. I'm not in the number.
خلينا نرمي. What is n?
Reaction force.
So it's multiplied by, or is it like a part of the
Maybe it's Newton.
first equation?
Like
It's Newton. Yeah.
Yes,
so-
Newton.
Yeah, yes, and it's Newton.
so it's the resultant force along x-axis.
Думай, зачекай.
F, for instance, multiplied by normal reaction.
No, I think it's Newton.
No, it's just Newton. See, meter per second, Newton. Degrees Celsius, kilograms.
It was a bit confusing. It's okay.
Degrees Celsius.
Okay, thanks. In my life, yes. We have my own physics, you know, like shield 1, shield 2, shield 3. Yeah.
Besides 30 degrees Celsius.
Okay. I hope you won't check my, let's say, as you know probably that each semester the professors should check TAs and professors should check other professors.
Yeah, I did.
So at least you they should do it. Right now, because we have videos, most professors are so lazy, they just open video and okay, I did it.
And you have only one TV.
What do you mean?
and theoretical mechanics.
So you're gonna cross-check yourself. Right?
No, it's not this. I mean, from other courses. So they have a table, but as for me, it looks like circus.
What? This
We need to mute the video.
Too late.
Yeah.
So I read research object.
Yes.
What is the next step?
Mm.
Describe motion.
Yes.
Yes.
Do you want to talk about body?
Well, we can consider it as a particle, right?
Yes. Why?
Because
We don't care about the size, maybe.
yeah.
So because you can consider it as a particle, we don't have any sizes. We don't need it there. It's not given. In terms of practical case, when we are talking about SLAM, I mean we have a car and we are moving for 1,000 kilometers. In this case, we don't need to consider the car. We can consider it as a particle. You have a small car, and in terms of 100 kilometers, 1,000 kilometers. When we are talking about car in terms of we want to drift, of course we cannot consider it as a particle. We have to consider even the wheels, even the yes. Что там делается?
Я еще не знаю, что правильно делал. И что я в принципе все равно перемены.
Ну да, fx просто я по оси x сразу отправил.
Если фикс это надо.
Да. У тебя же y еще есть?
Да.
Ну ты можешь выбрать свою систему. Забыл пиджаком. Миледи. Вон. So you always have initial conditions. Actually, you also have position, and you need to talk about conditions in terms of general coordinates, but generalized coordinates, in terms of velocity.
So like x dot not v0.
So x dot not v0. Because it's answered. If you want to simplify, you can simplify. Потому что c2 получится у тебя такой же, как и это, поэтому 1. И это неправильно. c2 0,67, а первое получается у нас c1. Сейчас найду его, скажу. У тебя ты сам выбираешь t нулевое. И x нулевое ты тоже выбираешь 0. И значит ты неправильно посчитал. Вот ты можешь прийти, вот у меня есть решение полностью. Я тебе говорю, вот сейчас мы дойдем, проверим, что оно неверно. c1 4, да, верно. А вот c2 нет. Значит ты неправильно интеграл. Да? Ну да, косинус нуля 0, да. Вот что у тебя слева от косинуса, это и есть твой ответ. 0,67 или что там у тебя? 1 из корень, это 1 делить на 3. Так, force analysis, it means that you, how to say, it's not equations what you're starting to write, it's you need to analyze forces. You are already starting to solve the task. You need to understand what force do you have, what you are not having, and so on.
Okay.
For instance, you don't know n,
Yes.
you know some, but you can, so you know force, but in terms of x-axis. You can divide p on x and y axis.
But we know fx, it's f.
Yes.
So it's
You need to write that we know f, highlighted that, I know it.
p we can find because we know fx.
Where can we find the cheat sheet for integrals, like the general form of integrals? The one that you showed at the beginning of the lab.
Again, what do you want to do?
We want to get the integral of like the x dot dot,
Mm-hmm.
and we want like exponential blah. Yes.
Нет.
Yes.
Извращенец. Извращенец. Да ладно, нет, нормально. Считай.
لا مش هتبقى لا احنا ممكن تجيبها بس كويس
مش هيجي
دول لسه ما امتحنوش
ده مسمين
انت كان عندك تلاتة كده عندك كده عندك ما هو لازم بالأدب ناخد 5 هو هتجيب السيارة هتلاقيها تختار انت عايز تعمل ايه؟ مش عايز تعوض بالعيشة كونسومس بس انا عملت في العين محتاج ان هو يجيب كتير اوي دي اللي
Так, куда ты C1 потерял?
عوض بالزيادة
Начнем с этого.
كوساينس
Короче, вот тебе.
زيرو يبقى ده بزيرو وبعدين يجيب ده بزيرو يبقى الصفر المفروض نشوف انا بعرف معاك دلوقتي اللي كان المفروض اشرحه ليه بعدين هو انا مجيت فاهم تاني مرة كوزين زيرو كام؟ لا كوزين زيرو بواحد ده زيرو ده زيرو
Если мы чисто раз поставили, чисто поставили, ну, это проще стало.
عشان الاستيكاتش اللي تبقى
Помнишь, мы делали прикольно?
Давай не
الأربعة دي صح والاثنين بوينت دي كتاب
Ты брал продажу для почему уже не появилась?
دي طبعا
Вот
دي
она
طبعا
была,
صورة
она была, я все.
ما
Я увидел бочку креста, я подумал, что будет плюс-плюс.
دي انت طلع صح انت
Я
طلع انت اللي حسبتيها انت كنت هتكتبي في صح
هي ما هي ام جي كوزين
Просто я вот не мог такой пользоваться, потому что я
ليه
сейчас...
تعمل فلوس على كده
Для меня это
مش عارفة
я вижу,
انا عايزة اعمل كوزين 30 والاسم على ام هي الاثنين
я скажу, хаос, что я почему-то
Interesting.
почему
هي
حاجة غلط ايه
اولا انت بتسلمش هي اولا سلم ساين شوف انت اسمه مش اللي انت شوف انت تعطي في thank you
Okay, if you solve, you might try to do this game.
ماشي
هو حتى كده كده الاثنين معايا
جي عندنا المفروض جي
ايوه ساين ساين 30 نص وضع هنا تساوي مستوى تبعي هنا لما بنتجرب بنقسم بنزود قرص واحد بنسمع قرص جديد بنسمع زودين كمان نقسم كده 4.9 مقسمناش على قرص جديد دايما طبعا اصلا دويت القلم كده لقيت شبح بيجري في الورقه لا كثير
Ну, 67 это было бы третье.
Это машина или нет?
4 с этим получается.
ايه دي اللي بعدها بي بي وي ار تي
Да, ну стой. Где там ты пошел? А, ты же перенесешь, у тебя получится. Ты его переносишь, и у тебя получится.
انت شايف كمان تحريتي بالورقه بسيط
على فكرة لما هنتكلم بالموضوع بس ما ننساش ما نتخانقش عشان ما نضربش وده إذا مش محتاج حاجة أو في حاجة إذا مش عايز تسألني في 6 قلت الشركة
So the answer is there.
Yes. To make it similar to the one here, we can take like 2/3 as a common factor.
ما رضيتش
Like this.
But it rotates around the axis CD.
Yes.
Yeah, so like this.
Yeah.
Yeah.
Yes.
القصد اللي بتلف كده
Yeah, the part itself is like, here is the axis and it's spinning like this. Yeah.
It's time trying to use how to say 3D printer which I bought to how to say print the stuff and show you. I need not to be so lazy to do it.
I can do models for extra 1 point.
Okay.
I can do all the models you want.
I can do this for money.
But you're not guaranteeing that it will be assembled, yeah?
What? No, I can assemble. I can assemble for extra 1 point. You can print it correctly for 1 point. You can make a business.
So now we are talking about Newton's blah blah for non-inertial system. This A now, it's not a particle, but it consists of, it's all the system. So again, system. So it consists of transport plus relative plus Coriolis. So we may say that, of course, it can be divided on tangential and rotational inside of it. I hope you understand it. So, to sum up, we used to write it in such manner. And this bullshit.
What is T phi r and phi?
Tangential transport, transport acceleration. it's negative, but force is positive.
I mean, like, what does the symbol mean? Like T, phi, R. What is T?
Transport, relative, release.
So it's just notation. It's not multiplied by.
It's like T multiplied by F.
Yeah.
Down,
so
down, down.
What
T
is T?
multiplied by F.
What is T
transport.
multiplied by F?
Maybe it's plus.
So this plus is plus.
Ah, fuck.
Okay, plus. I told you that T.
I thought it's T.
T. Could you find the difference? I thought that T is plus. T.
How do you always understand this, man?
Neural network. So again, it's quite. Our force has the opposite direction of let's say acceleration y because it's just rotation, and we are trying to neglect our non-inertiality using these forces. So they are not real; they are not existent. Don't cry. Okay, folks. Inertia has the opposite sign. I told you it's not a physical force. We needed to compensate. Yes, I said. Okay. R-O-1-1. A system consists. So in those cases we have one body. Now we have a system. Consists a particle M. It's a ball and tube AB. Nice. Now we are talking about motion. M rectilinear, AB rotational around CD, but conditions. Initial X dot X dot T. What is it?
For X0, so we're assuming the whole system?
Where is
Or
this?
Yeah.
So we'll choose it right now. It's a good question actually. But first of all, you need to understand that this, how to say, initial condition for
The wall or the whole system?
for whole system. So, either in the picture. M there. It rotates x-axis there. Because for my case, I can say that it depends on our system depends on the boundary system.
Where is it?
This one.
So our tube line.
Okay.
What do you take as a zero? M or the beginning of it? Or B? M or B? You take a zero.
0.
Yeah.
Maybe.
I choose this point, but our initial condition in this case,
Mm-hmm.
A.
Choose this point because we have like the distance.
Yes, we know the distance between this and this, initial time. Initial distance between point equal to A. It's easier for us to consider this because it's just point. We also know that it will be A with the same angle sine. No, sine. X0 is A, 0, 0. Final x1 we don't know, x2 we don't know, x dot we don't know, t1 we don't know. Now we have to consider kinematics analysis. What does it mean for us? We are putting their velocities, accelerations, and blah blah blah. We need to know directions of accelerations because of inertial forces. We cannot solve force analysis if we don't know where our forces should be positioned. As you remember, it should be in negative sign of your acceleration. Okay. What we are doing there? Arc release. It should be to omega r or to an other.
Actually, 2 omega E. V relative.
Now we are starting to draw. We need to read. So rotates around vertical CD in constant angular velocity. Let's put it there. Okay. Constant angle between always 45. A small heavy ball placed in there. Determine the motion of the ball, assuming the blah blah blah. Let's assume that our move. So let's start. It rotates like this. So our transport there. There is position there. It will be this. Transfer there. Our relatives. Take one extra color. So right now we are assuming that actually you solved on midterm for the day. Because kinematic analysis we are just forgetting about everything else if you just solve the kinematic. So we draw all positions. What we are doing there? Now we're going to cross omega r. In our case, it's cosine x because now m is moving. It's a, then x plus x. Plus x. In initial condition it will be A. So, to sum up, in our case, we don't need to think about Coriolis force because it's we have this axis, but Coriolis force looks in front of us. We receive it from this because of accelerations. It means that they're not existing in our equations. We have on transport force. Transport force, yes. Because it's perpendicular to normal, as you remember that. Actually, you have all of this there.
I mean,
So, and it's better.
Coriolis should be inside the board or outside the board.
It should be yes.
Okay.
Because acceleration there, so it should be there. And we have extra dot and this. And after this, we're just starting to solve this. So we can eliminate m. We're starting to solve, integrate it to times, and we are finding finally this one.
I have a question. Is the particle going up or down?
It depends on your decision.
Because if it's going up, Coriolis is going in. If it's going down, then Coriolis will be going up.
Let's think, when we are rotating, it should go after so it
Yes.
won't fall. So your acceleration should be there.
Yeah, but
Depends on the mass.
speed.
If
Yeah,
mass is big, then it will.
it will fall always.
In
And
this
it's
case,
a heavy ball.
In this case, your let's say, equation will change. You will have the problem sign. Or let's say, you
Like-
choose different sign, and or if you choose a different direction, in this case, your sign will be different, and you will just receive negative something, negative acceleration or negative acceleration, negative forces. In this case, you understand that you need to change the direction. I really recommend you because to solve this task, you have answer at home because I see that you didn't get. It was a bit messy on the whiteboard.
Один чертеж просто.
What again?
Чертеж вообще просто.
Да, просто бомба. I agree.
There it's much better on the, let's say, purpose.
So you also have this task. Actually, it looks almost the same, but in this case you need to find velocity, and you can find the solution on this book. With Michel Stiras, yes. Actually, that's it for today. I noticed. So to sum up, because I understood that you're a bit confused. When we talk about inertial system, we just solving this task, as we did recently, no problem. When we are going to non-inertial system, you need to remember how you are solving the task on kinematics using, let's say, complex motion. You just need to solve this task firstly. After this, you are going to force. That's it. In our case, we need it because we don't know the direction. We need to our force, let's see, our acceleration shows the direction for our forces. And how can we make a force analysis if you don't know the direction of forces? So making kinematics, you're receiving the directions. And in our cases, it's simple case. When you're going to the whole dynamics, it also provides you x respect to t. I mean, respect to angle or whatever.
But well, this is non-inertial, right?
Yes,
Why?
because
Yes,
you have Coriolis acceleration.
but it's like it says with constant angular velocity, so ignores accelerations. You said it's only when acceleration is.
You have transport acceleration.
Yeah, you said when we have like transport acceleration, not velocity. So it has angular velocity constant.
Again, when we're talking about Coriolis acceleration, it consists of angle.
Yes, and v rally. Yes,
It moves this point m.
yes. And omega also, we have omega. So
In this case, we already have acceleration. That's it.
so not acceleration of the frame, acceleration of like Coriolis acceleration. That's my question.
Our frame is x.
Yes, and it moves in constant omega for all x.
Yes, but actually we're receiving acceleration. We're talking about linear acceleration.
Okay.
Because linear acceleration equal to what? We have it's omega r. Normal.
I don't understand it from the equation, but intuitively, if we are revolving around the axis, then our radius is getting bigger or smaller, so the velocity is changing, and then we have acceleration by default. Like intuitively, I don't
Actually, if we
understand
have
it from the
rotation, in
equation.
this case, you can think that we have acceleration. Yes, linear acceleration. Because we are talking about linear acceleration in this case. So, it's not, is it? Time to like Tiffins.
When will we have grades
Grades?
for forecast?
Thursday. Because we will have on Thursday we will have not appellation like this, but we will not review. Yes, we will discuss what mistake the group did. I will present you the solution, my solution of the first home task, research home task. You're showing your solutions if it will be good enough, and also I will present you the second research home task. And we will have quiz.